Hello, welcome back. Hi, how are we doing? Good, good. All right, so today we're going to work on 4-5, but I want to take a moment to look back at what we've already done with triangles. So we identified them, right? And then we talked about the angle measures, and then we started talking about how to figure out if triangles are congruent. And our first step in figuring out if triangles are congruent was to look at this corresponding parts of congruent triangles or congruent mess, this stuff, which was our definition of congruent triangles, that in order for triangles to be congruent, all the different pieces of them have to be congruent. Yeah? So you have to have 3 pairs of congruent sides and 3 pairs of congruent angles before you could state these triangles were congruent. Problem is that took forever, right? There's a lot of work. So we shortcutted it. And that was section 4.4, last episode, where we pulled in side, side, side postulate. Now all you needed was 3 pairs of sides to show triangles were congruent. We also pulled in side, angle, side, where all you needed were 2 sides and the angle between them to show that the triangles are congruent. Today's episode is focusing on ASA and AAS. Thinking back to last episode, SSS stood for side, 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 and SAS stood for side, angle, side. Based off of that, what do you think ASA stands for?
Angle, side, angle.
You're absolutely right. Go into your notes, find where that postulate is, and then I'd like you to please leave a note for yourself here that ASA stands for angle, side, angle. So here is our angle, side, angle postulate. Based off of what you recall, what do you think AAS stands for?
The side. Well,
Angle, angle, side.
Angle, angle, side. So on your second page of notes, I'd like you to please find the AAS theorem, and please make a note for yourself that this stands for the angle, angle, side theorem. Oh, I colored that box ugly. All right, so now we have 5 different ways to prove that triangles are congruent. You can use the actual definition of triangle congruence, or CP/CTC, corresponding parts of congruent triangles are congruent. Bless you. You can also use SSS, which stood for side, side, side. Bless you. We also had SAS postulate, which stood for
Side, angle, side.
gorgeous, side, angle, side. And today we're adding ASA, which stands for
Angle, side, angle.
angle, side, angle. Bless you. And we'll be adding AAS, standing for
Angle, 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 side.
you guys are awesome. Please note, bless you. It's okay. You're allergic to triangles. Me too. Please note that the angle, angle, side is the only one of these that is the theorem. All the rest are postulates. Remember that the difference between the two is a postulate is, okay, boss, I believe you, it's true. And the theorem is, no, prove it. Bless you. Okay? All right, you'll see this page pop back up again if you're not done writing, so you'll have a chance to catch back up. Let's fill in our vocabulary. Included side. Last episode, we had the included angle. That was the angle between two sides. What do you think an included side is going to be?
The side between two angles.
You're absolutely right. Go ahead and update that now. The side between two angles. There's the kind of bookish definition. As soon as she gets back. Thanks. It is the side between two angles. So if I have these two angles, that side is the one we're talking about. Here's what the postulate angle side angle says. If two angles and the included side of one triangle are congruent to two angles and the included side of some other triangle, then the two triangles are congruent. So here's what the picture looks like. Note, two angles, two pairs of congruent angles, and then the side connecting the vertices of those angles are congruent. You're done writing, start looking at the proof. Okay. I'm going to start working on the proof. Sorry, I see some people still writing.
A lot.
Yeah, I still see a lot of you still writing, so I'll give you some more time. If you're watching and you're still if you're done writing and you're watching this, you can fast forward. If only we could fast forward in real life.
The good parts.
Right?
We have the trash parts, all the trash people, the trash boys, you know.
All right, let's start looking at this two-column proof. Most of you are done writing. So we've got a given, we've got a proof, and we have a diagram. First thing to do is look at how the given affects the diagram and see what that can tell us. So I'm going to start using my highlighters and my colors to make our given reflect on our diagram. So my given states that line segment AB and line segment CD are parallel. So those are the two line segments that we're talking about, AB and CD, and we're told that they are parallel, which means I need to put in the little arrowhead. It was already done for us, but I went ahead and made it more visible. The next thing that this says is that angle CBD is congruent to angle ADB. Angle CBD, I don't have a line that connects B to D. Make one. Put in that auxiliary line. Between any 2 points there is a line, so I'm allowed to draw a line between any 2 points whenever and wherever I want. As long as it's helpful, I can do it. I definitely need one, so I'm going to go ahead and do it. Doesn't have to be the best, most perfectly straight line ever. Just get that line in there. We drew an auxiliary line. And now I'm able to state that angle CBD, this angle right here, is congruent to angle ADB, this angle right here. Because I have my auxiliary line now. All right, that's all I have. I need to use this information to prove that this triangle here, triangle ADB, that's this one right here, is congruent to this triangle CDE. DB, which is this triangle right here.
So whenever we want, we can add an auxiliary line, right?
Yes, sir. And it's entirely possible, having written many proofs myself, that I draw an auxiliary line and I start working on it and I realize, well, that didn't help. It just made it a big mess. That's all right.
I forgot what that was.
An auxiliary line, it's a line that wasn't on your original drawing that you added in order to help you see things. In this case, I needed to create those angles. Okay. Let's go ahead and start filling in what we know. We were told here, the first statement, line segment AB parallel to line segment CD. Why do we know that?
Because of the given.
Because it was a given. Very nice. The next thing says we're going to have some more givens. So what should I write?
Angle CBD is congruent to angle ABD.
Beautiful. As a chorus, I loved it. The next statement says angle ABD, angle ABD, this angle right here, is congruent to angle BDC, this angle right here. We have to figure out why. They're alternate interior angles. Notice the orange lines are parallel. The auxiliary line we drew in can be a transversal. And whenever I have parallel lines cut by a transversal, alternate interior angles are congruent. And let me show you the back notes that gives you that. Here we are in 3-2. I have, if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. And so this would be the reason on number 3. Alternate interior angles theorem. I think I may have misspelled a word in there, I'm sorry. Next reason states reflexive property. The reflexive property is a property that says what?
A thing is equal to itself.
A thing is equal to itself or a thing is congruent to itself. Absolutely right. Now, if we look at this figure, there's a lot of things we could say are congruent to itself, right? We could say that AD is congruent to AD. We could say that CD is congruent to itself. We could say that this angle is congruent to itself. We could say anything. The trick is,
B, D.
which one is helpful?
B, D, because it's a side.
He's saying the side BD, the auxiliary line that we added, because if I look at this side right here, I notice that it belongs not only to this triangle, but it also belongs to this triangle. And so by saying that that side is congruent to itself, I'm saying that the segment BD, as it belongs to the triangle on the bottom, is congruent to line segment BD as it belongs to the triangle on the top. Which is important because our theorems require pairs of sides and pairs of angles. And so we're going to apply the reflexive property to that segment that's there being shared between the two triangles. What's your question?
I don't know, I'm just really confused about this.
Okay.
Just keep on going, keep on going.
Okay. Chew on it, and if you come up with a question that'll help clarify the confusion that you feel, let's hear it so we can address it, okay? Okay. Now we need to know, do we have enough information to show the triangles are congruent? Our partially completed proof says that yes, we do. Now we have to think back of the ways we have to show triangle congruence. We can use a definition, which is we need all 3 pairs of sides and all 3 pairs of angles congruent. Do we have all that information?
No.
No, so we can't use that one. The next one that we have is side, side, side. which requires all 3 pairs of sides congruent. Do we have all 3 pairs of sides congruent?
No.
No, we only have this one pair of sides congruent. This side, which is part of this triangle, congruent to this side, which is part of this triangle. And I don't have any information on these two. So I don't know if they're congruent to each other or not. Yes, they will end up being congruent, but I don't have anything that says they are now. So I can't use side, side, side.
Angle, angle, side.
I can't use side, angle, side either for the same reason. I only have one pair of sides congruent, which means I'm looking at the one we're working on right now, which is angle, side, angle. So let's point at those different pieces so that we can see how they work. Here's one pair of angles congruent. Here's one pair of sides congruent. Here's the second pair of angles congruent. Notice the side is between the 2 angles. And so angle, side, angle postulate gives us the information to state, bless you, that those triangles are congruent. Do you have a question yet?
I think mostly I just got lost. I can't see where it's an alternate interior angle. Like, I don't know, the transversal just confused me.
Okay, so,
And then after that, I'm going
and then after this it kind of, blah, blah, blah. Okay. Then let's move to the next one because it has something similar. And if after that next one is still a little weird, we'll turn off the current. I'll come over to you and we'll kind of refresh the lines and transversals. I think once you see that refresher, it'll be like, oh, I get it. Yeah? Okay. All right, we're going to skip the paragraph proof. We'll use this as a one-on-one if you're needing some more help. I'll leave it as an extra example during tutoring moment, okay? Let's go ahead and move on to the second page of notes. And here's what the angle side theorem says. If 2 angles, count them, 1 and 2, are congruent to, and the non-included side. Notice that this is one of the sides that's not between the 2 angles. But there's a difference between this theorem and the postulate that we just looked at. Where the postulate said 2 angles and the side between them, this one says 2 angles and the non-included the side not between the angles, congruent to the corresponding 2 angles and side of another triangle. So in the first postulate, it didn't seem to matter whether they were corresponding or not. They ended up becoming that way. On this one, you have to match up corresponding sides, corresponding angles. So look very carefully at the diagram that I've colored for you. And notice that the side that was not included in this particular one was the one that came off of the angle I colored in blue, not the angle that I colored in green. They have to match up.
And how would you prove it?
How would I go and prove this theorem? Because it's a theorem, it has to be proven before we can really use it. That's an extended one. Can you and I sit down and work on that proof as an extension later?
Yeah.
Okay. Some of you are still copying that down. So I'll give you guys a few more seconds. If you're done copying, go ahead and take a look at the first example. Start trying to piece together what you might want to do. All right. In this diagram, we're told that angle BCA is congruent to angle DCA. BCA, this angle here, congruent to DCA, this angle right here. Which pair of sides are congruent?
AC.
AC this AC as it corresponds to the angle on top is congruent to this AC which corresponds to this triangle on bottom. That's that reflexive property that got used in the previous proof.
They're congruent because they share the same thing.
They're congruent because they're the same thing. They're the same segment.
Well, it's AC to AC.
Exactly. And it's the same segment. It's just that one segment is getting used by both triangles. Yeah? Okay. The question is, what additional pair of corresponding parts need to be congruent in order for us to use the angle-angle side theorem to state the triangles are congruent? Well, for angle-angle side, what information do we need to have? How many angles? How many sides?
2 angles.
2 angles. And-
Non-included side.
And the non-included side. One pair of sides, but it has to be the one that's not between the angles. Looking at our diagram, how many pairs of angles do we have congruent? We have 1 pair, the blue one. And how many pairs of sides do we have congruent? 1. So we're missing a pair of angles. And we want the one that isn't going to put the side between the 2 angles.
Angle B, angle ABC.
Exactly.
Angle
This angle and this angle. Those are the only angles that you can choose such that the side is not between the angles. So we're going to write that as a sentence. I need angle B to be congruent to angle D in order to use angle-angle side theorem for triangle congruence.
Sorry. I just got excited.
When you're done writing, start looking at the final 2-column proof practice. All right. Yep. Yeah, I didn't end up writing here. I just marked it on the diagram. Okay. So I'm taking a moment and I'm adding in some lines here in my 2-column proof so that I have spaces to write in. And I'm going to go ahead and take my colored markers and I'm going to start highlighting the different pieces. AC is parallel to EF. So I'm going to make sure I have that marked down. And I'm going to go ahead and write it in my statement box. And make sure that I write that it is parallel to and not congruent to. Like I started to because I'm dumb.
Nobody's dumb here.
Oh, you're right. I was careless. Better?
Yes.
Okay. I also have that line segment AB is congruent to line segment DE. There is AB, there is DE, there is my marking for congruence. And then I'm told angle C congruent to angle F. Here is angle C, here is angle F. And the one arc in them means they are congruent. I need to show that triangle ABC, this triangle right here, is congruent to triangle DEF, which is that triangle right there. All right, finish writing out the given, which I didn't do. All right, the second statement rather, says that angle ABC is congruent to angle DEF. ABC, this triangle, this angle here, congruent to DEF, this angle right here. And the question is, how?
Corresponding angles.
Why did it go straight to the proof for number 2?
We didn't go to the
Dumb,
proof.
I'm dumb, sorry.
Okay, that's all right. No one's dumb here.
Dumb here.
All right, so you had said that these two angles are corresponding.
Yes,
If
because-
I extend these lines out,
That would make it.
and I extend this line out, color it in purple, make it easier to see,
Perfect.
I see that I have some lines cut by a transversal. They definitely look perpendicular, and I have a feeling that if I took the corner of a sheet of paper or a protractor, I could measure and say that they're 90. But in proofs, we don't want to use a measuring tool because the measuring tool could be wrong. Okay? And with proofs, everything has to be exactly true all the time, always. We can't have or allow for a measurement error in a proof. Okay? But what we can say is that these are corresponding angles. If we notice our transversal, they're both on the same side of the transversal. One of those angles is between the lines that was intersected. One of those angles is somewhere in the outside exterior portion of those lines that got intersected. And so these angles are corresponding.
Corresponding angles.
We have in that section 3.2, talking about corresponding angles, we have the corresponding angles postulate that says if two parallel lines cut by a transversal, corresponding angles are congruent. And so the reason for number 2, and the reason is corresponding angles postulate. And now this says that by angle, angle, side, we can say something.
Triangle ABC is
Triangle
congruent to
ABC is
triangle
congruent to triangle DEF.
You're absolutely right. Triangle ABC is congruent to triangle DEF, and we can say that from the angle, angle, side theorem. Please add the word theorem. I don't know why it was left off. Because the conclusion of the theorem is triangles are congruent. That's all I had for you guys today. Thank you very much.